Today we're talking about graphing quadratics in intercept form. Hey guys, Jesse from Capstone Academics here. Today we're going to be talking about graphing quadratics in intercept form. It's actually going to be a pretty short video. There aren't a whole lot of subtypes to address, so let's get right into it. Also, be sure to hang in till the end because there is a 2-problem test, which if you can pass means you're ready for your quiz, your test, midterm, final, or SAT or ACT. You'll be graphing quadratics when the equation has the format y equals a parentheses x minus p x minus q, where p and q are the x-intercepts. Now, first things first, I am going to put a picture on screen of the process for graphing these, just so you guys can pause it and take notes, or take a screenshot, or download the image using the link in the description, whatever you find easiest. But in any case, you will want to review it just because it's going to be a little bit easier if you have the whole process sort of in mind before we start. Now that you guys have a basic idea for the process, let's jump right in. Okay guys, so to get started, all you have to do is set y equal to 0 to go ahead and find your x-intercepts. So when something is factored like this, all you have to do is take each independent factor and set them equal to 0 to find your two solutions. So when you algebraically solve for this one here, you just add 2 to both sides, you just get x equals 2. Over here, add 4 to both sides, and you get x equals 4. So the two zeros are at 2 and 4. And then for your next step, you know that the vertex is going to be somewhere along this line, because the parabola is going to cross through at 2 and 4. So it's going to be like that, or even if it's upside down, it'll look like this. But either way, the vertex is going to lie somewhere along this line. Now, it's obvious this time that the x-coordinate of the vertex is going to be 3, because it's in between 2 and 4. But a lot of times, it's not going to be that easy to just tell where it's going to cross through. So the process for this is you actually average the x-intercepts. So that means adding them up and then dividing by 2. So 2 plus 4 over 2 is 6 over 2, and then there's the 3 that we expected. So the x-coordinate of the vertex and also the equation for the axis of symmetry is at x equals 3. Now, we'll need to get the y-coordinate of the vertex by plugging this 3 in for the x and just solving. So it's like y equals 3 minus 2 times 3 minus 4. So y equals 1 times 3 minus 4 is negative 1, and then y equals negative 1. So we go and we plot that at 3, negative 1, that's down here. So that's our third point. This is usually all teachers require, but you could just do a table of values for your 4th and 5th points if your teacher requires 5 points. All right, so let's look at one more example where you actually have a negative x-intercept, so it sort of highlights the importance of averaging the two zeros. So again, starting off with plugging in 0 for y to get your x-intercepts, so just x minus 1, x plus 3 here, set each one equal to 0, and then just algebraically solve for each one, so just add the 1 over. So x equals 1, and then x equals negative 3. So you got one of them at 1. The other one at negative 1, negative 2, negative 3. And then you average your zeros to find the exact middle of this. So some of you might recognize instantly it's going to be negative 1, but trust me, when you start getting decimals for these x-intercepts, you'll want to know this averaging trick, okay? It's not even really a trick, it's like the method you use regardless of whether it's clean or not clean, right? But you add them up, so 1 plus negative 3 all over 2, so that's 1 minus 3 over 2, so negative 2 over 2, so negative 1. So we draw our axis of symmetry at negative 1 because the x-coordinate of the vertex is at negative 1. Plug that in to get your y-coordinate now. So this, and then negative 1 minus 1 is negative 2, and then in between here is multiplication. Keep that in mind. So it's like times negative 1 plus 3 is 2, so y equals negative 4. So going down to negative 4, negative 1, negative 2, negative 3, negative 4. There it is. Vertex is at negative 1, negative 4, and then draw your parabola. And this is enough for most teachers, but table of values if you need more points. Okay guys, in this example, we're actually going to talk about the influence of the a value, or this term in the very front here. So basically what you want to remember is if a is negative, it's going to flip the parabola upside down. And if the absolute value of a is bigger than 1, so in other words like 2 or 3, or even negative 2 or negative 3, then the parabola is going to grow 2 or 3 times as fast, which gives it a skinnier look. Okay, it's really narrow. But if the absolute value of a is in between 0 and 1, so like 1/2 or 1/3 or -1/2 or -1/3, then it's going to have a wider look. Okay, whether it's right side up or upside down is determined by that negative, but basically if it's a proper fraction it's going to be super wide, but if it's a number bigger than 1, essentially it's going to be skinnier because it's growing faster. So we're going to see that happen here. We are just going to start with setting y equal to 0 to get our x-intercepts, so that's going to look like this. And then the -2 here actually isn't going to influence the x-intercepts themselves. So just to prove that, I'm going to divide both sides by -2. You do not have to do this. I'm just proving that -2 doesn't actually influence the x-intercepts themselves. So back here, you could have just set x plus 4 equal to 0 and x plus 6 equal to 0, but I just wanted you guys to see that -2 disappear so you can see why it doesn't matter. But in any case, here we go, setting these equal to 0 and solving. So you get x is -4, and then x is -6. We're going to go ahead and plot those, -1, 2, 3, 4, and -6. And we're just going to average those to get the x-coordinate of the vertex, so add them up and divide by 2. This is -4 minus 6 all over 2, -10 over 2, and -5. So there we are. The x-coordinate of the vertex and the axis of symmetry is at -5. And then plugging that in to get the y-coordinate of the vertex. Now, this time the -2 actually will influence our result, as you'll see here. It's -2 times this is -1, and then this is +1. So y equals -2 times -1 is +2 times 1. Y is 2, so go up to 2. And as we'd anticipate here, the a is negative, so it is going to be upside down, and the 2, the absolute value of a is bigger than 1, so it's going to have a skinnier look. So upside down and skinny as we'd anticipate, so not too bad. If you guys are finding this helpful, please do go ahead and hit the like button. Thank you so much. And now for kind of a weird case where you actually get 0 as one of your x-intercepts. It looks weird to most people, so I just wanted to address that real quick. Okay, so as we've discussed, even when things look weird, make sure you use the same processes, right? So this x out in the front definitely looks weird, but again, we start with setting y equal to 0. So we're going to find our x-intercepts this way. Now, when there's an x out here, remember the -2 in the previous example didn't matter, didn't impact anything? That's because it didn't have an x, right? But here, basically this times this equals 0 is what we're setting up, right? So from this term outside here, you actually have a value of x that could make the whole thing end up equaling 0. So you have to account for that. X could be 0. That's one of your solutions. And then x minus 2 could equal 0. And then you solve for this one, and you get x-intercepts at 0 and 2. So at 0 and 2. And then once again, we're averaging. I'm getting you guys used to this in case your numbers are actually bad. In my examples, they really haven't been, but sometimes you'll have decimals for these, you will need to average them. So add them up and divide by 2. So 2 over 2, so x equals 1. So axis of symmetry is at 1. Plug in your x value to get the y-coordinate of the vertex. So 1 times 1 minus 2, so 1 times -1. So -1 for the y, that's right here. That's your last point that you need. Draw your parabola and you're all set. So not too bad, but just remember, whenever there's an x on the outside like that, it just means that x equals 0 is going to be one of your zeros. All right, gang, time for the 2-problem test. If you can pass this on your own, you're good to go. Okay, so this time we have a fraction in the very front here. Now, that is going to make it wider, as we discussed before, and the negative is going to make it upside down. So we can expect a general shape to look like that, right? Obviously, those aren't going to be the zeros, but we're going to find those. So here we go, setting y equal to 0 to find our x-intercepts. Now, we ignore that 1/2 on the outside. It doesn't influence the intercepts. So x minus 1 equals 0, x minus 3 equals 0, and then we're just solving. We get 1. And then 3, we'll go ahead and plot those. So 1 and 3, put our points down, and then we're going to average the zeros, 1 plus 3 over 2, to get our x-coordinate of our vertex. 4 over 2, 2. So axis of symmetry, or the x-coordinate of the vertex, is at 2, somewhere along that line. And then plugging that in to get the y-coordinate of the vertex, so 2 minus 1, 2 minus 3, I would save the 1/2 for last, guys, not that it really matters, but like 2 minus 1 is just 1, 2 minus 3 is -1, so -1/2 times that's going to make -1, so that is positive 1/2. So that's right here at positive 1/2, or like 0.5 is the way you can think of it. And as you can see, we have a wider looking upside down parabola, just like we anticipated. So not too bad. Last one, guys, here we go. So setting y equal to 0. We remember if there's an x on the outside, like we're seeing here, then we're going to get a solution out of that. So you set the 4x equal to 0, divide by 4, and x equals 0. And then from this one here, x plus 2 equals 0, minus 2, minus 2, x is -2. So our zeros are at 0 and -2. And then average the zeros to get the x coordinate of our vertex, so like 0 plus -2 over 2. So -2 over 2, x is -1, which is super obvious, but again, for when they're nastier, we should be doing it this way. So plug in your -1 for your x, so it looks like that. And then 4 times -1 is -4 times this is +1. So y equals -4. So if the vertex is at -1, -4, here's -1, -1, -2, -3, -4 for the y. And as we anticipated from this a value of 4, it's going to be right side up, but that 4, the absolute value of a is bigger than 1, so it's going to end up really skinny, right? So there we go. It's just growing 4 times as fast as usual. That's why this ends up looking like this. Lastly, most of the time you guys are going to be graphing quadratics in standard form and vertex form as well. Typically teachers start with standard form, so that's probably what you saw before this. But in any case, all 3 forms are actually on the SAT and the ACT, so you'll want to know these pretty cold. I do have videos on standard form and vertex form, which I'll put links to at the end of the video. Do go ahead and check those out. They are super helpful. And that's all for graphing quadratics in intercept form. I hope you guys found this helpful. Please do go ahead and subscribe for math help all year long. Thanks so much for watching, guys. See you next time.